Welcome back, everybody. Today we're going to start our lesson on sets and dictionaries. So the first one is the sets. Okay. So we're going to learn about before we get into sets, we're going to learn about hashability of an object. Then we're going to start learning on sets. Then we'll learn about practice set operations and set comprehension. And then we end up doing some practice with sets. So let's start. All right. So what is hash? What is this thing called hash? Okay. So okay. So basically, it's a fixed length number that it can uniquely identify some data. Okay. It's a fixed length integer basically that uniquely identify some types of data, and we'll learn what are they. Okay. And it's a efficient. It provide an efficient process to in representing large data. Basically, it provides a mapping mechanism between large amounts of data into those hash values. So hash function create a hash value. And there's a data structure called hash table, which basically uh, map a set of hash values into data. Okay, so hash table basically maps data into hash value. So it's a table of hash values. So hash tables are really efficient in terms of searching, deleting, and inserts. Okay, so usually it's single instruction. Okay, so in a order one process, so in just single instruction, you can search for an item in hash table. Okay. All right, so let's talk about object hashability. Okay, so there's a built-in method called hash function. Okay, built-in function named hash. Okay, and we pass our object into that, and then it returns the hash value. Okay, so basically, to get the hash value, basically we pass our object into hash built-in function. Okay, it only returns hash value if it has a one. Basically, if the object is qualified to get a hash value, then it returns one. Otherwise, it will return an error. Okay. So a hashable object basically has a constant hash value during its lifetime. So it's never changed during its lifetime, and they can be compared to other objects. Okay. So So the hashable object that compare equal have same hash value. Okay, so if two object has same hash value, if two objects are equal, then they should have same hash value. Okay. So usually most immutable objects are hashable. Okay, so if the immutable containers has all element are also immutable, then they are also hashable. Okay, so for example, if we try to get the hash value of this tuples are immutable, that's what we say, but this tuple has a mutable list inside. So this entire tuple is not hashable because of this immutable list inside. So it returns a type error saying unhashable type. Okay. So for the user-defined classes, objects of user-defined classes, they are hashable by default. Okay. So the hash value is derived from the ID value. Okay. So ID, we use the ID function to derive the hash value of user defined objects of user defined classes by default. Okay. All right. So let's check this out. Okay. So I'm going to go to my PyCharm again. It's formatted. Okay. So it's a long file. Okay. So I recommend to follow the lecture and build this one. Okay. So or you can also download and then run it, run the file that I uploaded as well. Okay. All right. So first we're gonna basically it's slide 3. Okay. So I'm gonna print the hash value of 1. You'll see that it is actually 1. Okay. All right. And then I'm going to print the hash value of Python. Okay. And it has a different value. Okay. Let's try this out. Okay. So I got 1. The hash value of 1 is 1. And hash value of Python is this. Okay. All right. So then let's try this. Now we're gonna uncomment this. Well, I'm going to uncomment this and rerun. Okay. So basically, oops, this one and this one. Okay. So I'm trying to now get a hash value of a list. Okay. So this is not possible for now. Okay. So, and in here, I'm trying to get a hash of a tuple that has a list. So both these operations are actually um, illegal. Okay. So let's run the first one. Okay. So we got type error, unhashable type list. I'm going to put it over here. Okay. I'm going to block it. Okay. And rerun with this one. And I think same error. Okay. All right. So over here, unhashable type list. Okay. Same error over here. All right. So I'm going to, so, all right. So if you try to get a tuple, basically you can hash at this tuple because it doesn't have any mutable object inside. So hash this one, and we get a value for that too. Okay. All right. So we have this. Okay. All right. So let's go back to our lesson. So we are going into 4th slide. All right. So let's talk about sets. Okay. So sets, mathematical set basically set of unique values that can be grouped into one. Okay. So for example, students of this class, all of them are unique and we have a set of students, right? So um, number of digits, it's a set of numbers from 0 to 9. Okay. So they are unique values. Okay. They are not duplicates. Okay. So basically mathematical sets, Python basically implements this the analogy of mathematical set. Okay, the theory of mathematical set. Okay, all right. So Python set it's an unordered, okay, unordered collection of distinct hashable objects. So these are really important words. Okay, unordered. So if we take a list, it's ordered. So we can actually have an index and then go index one after the other, following the index. In a set, you can do that. Sets are unordered. Okay, unlike strings, tuples, lists, sets are unordered, and they're the collection of distinct element. Basically, all the element inside they are distinct. Okay, and those element must be hashable. So that means they're actually immutable object. They must be immutable object. Okay, so items could be numbers. Numbers are immutable in Python. strings are immutable in Python. Also, it could be immutable containers that filled with immutable elements. Okay, like a tuple with all immutable elements inside. Okay, so sets can only have immutable elements inside, but as a whole, set is a mutable object. Okay, so there are immutable version of it's like we have the immutable counterpart of lists as tuples. We have immutable counterpart of sets as frozen sets. Okay, so frozen sets are immutable. So there are a valuable set of operations from sets. So the sets provide these valuable operations. So we can do efficient membership test. Okay. So basically, it's a single instruction membership test. So if we are to test the membership of an element in a list, basically we check element by element and which one is in there. Okay. So the in operator does it. Okay. So in fact, in operator go inside and check each element against, right? But in operator in sets basically use a different procedure, which is the hash function. So it's used the hash function and they are unique. So uh, it's directly mapped to the object inside. So it's a single instruction. Okay. So it's really efficient. So membership test or lookups are really efficient. So removal of duplicates, you can do it efficiently as well. Okay. Because when you create a set, you only absorb all the unique and distinct values, right? So then basically you can remove duplicates in a list of other stuff, right? Objects, okay? And set supports these sets operation, union, intersection, and more, okay? So basically it supports all the mathematical set operations, okay? So let's see how we can create a set in Python, okay? So first you can we use a set literal we can create a set literal by enclosing the things that we want to create a set out of in this curly bracket. Okay. So if we enclose this set of numbers in two curly brackets, we're gonna get the set literal 1, 2, 3. So notice the removal of duplicates. So only 1, 3 we have. We have three C's, three threes over here. We have only one. Okay. So basically it returns this set. Okay. But be careful, if you want to create an empty set, you cannot use the two curly bracket like this because it's going to create an empty dictionary, not an empty set. Okay. So to create an empty set, you can basically call the set function just directly like this without passing anything. Okay. So to create a set out of any iterable entity, okay. So basically, there shouldn't be this mark over here. So let me just quickly adjust that. Okay. So shouldn't be it's two, not two square bracket, just the iterable. Okay. So all right. So we can also use set method, set a built-in function. Okay. So that is okay. So basically, you can pass any iterable object into set uh, built-in function, and it's going to create a set for that for us. For example, if we pass this list into set, and you can create this set out of it. Also, this is a set built-in function provide a way to create an empty set as well. So we just directly call it like this. So to create a frozen set, basically we can call frozen set and pass the iterable. So here also should be, okay. So to create a frozen set, we pass the iterable object into frozen set built-in method. Okay, so this will create this frozen set. Okay. All right. So let's check this out now. I'm gonna go over here. I'm going to unblock this code. Okay. So all right. So I'm gonna first unblock this. Okay. So I'm creating this a set out of these numbers. So let's print that out first. Let's run it. Okay. So we have the set 1, 2, 3. Okay. So excuse me. So let me unblock this and all of these. Okay. So set one. So you're going to take the type of set. Okay. So we're going to verify the type is set. Okay. And all right. And then I'm going to use curly brackets. Okay. And you'll see that set two is actually a dictionary. So I'm going to print the type of set two. And you see that it's a dictionary. Okay. So run it. Okay. So first one is a set one. The set two basically set sorry, set two. Well, that's okay. So this should be empty. That's why. Yep. This should be this. Sorry about that. Okay. Oops. All right. So let me run it again. Okay. So set two is a dictionary. Okay. All right. So and then if you can pass any iterable object into um, set method. So let's run this one as well. Okay. So set three. So I'm going to print set three. So I'm passing this string, and we see that I'm going to get unique set of characters in this string. Okay. All right. So okay. So I got the set of characters unique. Okay. So this distinct, right? See, we have two O's over here, but we only have one O. And you can see that the order is also not this order, right? So that's one clue that okay, sets are unordered. So that's you cannot rely on that order. Okay. All right. So now I'm going to show you. I'm going to try creating um, a set out of a list. Okay. So say set three. So let's see. This should be um, this. Okay. All right. So I'm trying to create set, but I'm going to I'm passing. Um, well, let's see. Oh, okay. So this is actually something else. So basically, now I said set objects. Sets are not they are noded. So there's no notion of the index. Okay. So that means basically we cannot access an index. Okay. So it's right here. So this should be this way. So I'm trying to print the index one of this set three. But notice you will get an error. So let's try to print this. Okay. So type error. Okay. Set objects are not subscriptable. Basically, there's no index. That's why. Okay. So that's the error. Okay. So let me comment it out. Okay. All right. So let's print. Okay. So sets are mutable object. Okay. So basically, let me just print this one. Okay. So we're gonna basically prove that. Okay. So I'm going to basically okay. So what I'm going to do is basically uh, I'm going to first print the ID of this set3. Okay. So the ID value. Okay. So notice every object has an ID value in Python, right? So then I'm going to add using add method. Okay. So if this is allowed, that's an indication, okay, so this is a mutable object. Okay. And then I'm going to print set3. Okay. Again, the ID of set3. Okay. So basically I'm going to print it again over here. Okay. And run it again. Okay. So we have, okay, so the first ID is this. Okay. The first set, which is basically this. Okay. And I have the ID this. And then I basically added programming. So I have now programming also there. Okay. All right. So it's the entire string programming is also there. Now I basically check the ID again and it's same. Okay. So basically there was no copy created, right? Basically, it basically added into the same object, same set that is referenced by this ID. Okay. All right. So let's go back to our slides. Okay. So let's create a frozen set as well. Now come over here and create a frozen set. Yeah. So right here. Okay. All right. So set number 4, I'm going to print it. So this is a frozen set. Okay. So basically it created the frozen set. Okay. So that's how the Python print frozen set. It's actually spell out the word frozen set. Okay. So now basically I'm going to try adding programming to frozen set. Okay. So let's try to do this. Okay. So, all right. And then basically run it. Okay. So I got another error. Okay. Saying attribute error. Frozen frozen set object has no attribute add. Basically that means add is illegal. Okay. So there's no such attribute. Okay. All right. So let's go back to our presentation now. All right. All right. So let's go over set operations. Both sets and frozen set provide this following operation that we're gonna see now. Okay. So first is the length. Okay. Basically, length of a set is basically there's a definition to it in mathematics. We call it cardinality of a set. Okay. So we can use the len built-in function to get the length of a set because set is a container. So any iterable object, we can get the length out of that iterable object using a len function. Okay. All right. So and the membership check. Okay. So we learned how to check the membership. So we can check an element for its membership in a set. Okay. So if X is in the set a set and it returns true. Okay, so otherwise it returns false. Okay, and if you want to test non-membership, then it's a not, you have to use not in operator. Okay, and both these operations are basically single instructions. Unlike a list or a string, in operator works single in a single CPU instruction because of the nature of this sets. Okay, all right. So the next operation is disjoint. Okay, so basically, if 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 two sets, okay, one is a set and the other one is we pass into is disjoint. Okay, so if the two sets don't have any common elements, we call it disjoint. Those sets are disjoint. Okay, so if basically uh, if the two elements are disjoint, basically then this returns true. Okay, so basically um, that means there's no intersection, right? So that's what it means. So disjoint only if the intersection is empty. Okay, all right. Is subset. Okay, we can check the other set is also subset in a set. Okay, so we can also use this operator as well, checking on okay, checking on the subset. Okay, so it's really versatile. You can either use set method or the operator. They both works the same. Okay, and this says a set less than or equals other. Okay, so basically and then whether it basically checks whether every element in a set is also in other. Okay, all right, it's subset. So let's check on these. Okay, we'll go back to PyCharm. Okay, so all right, so right here, so I'm gonna unblock these. Okay, so I'm going to create a set. Okay, and then I'm going to put the coordinate of that set. Okay, then we can check the uh, membership. Okay, let's run it. Okay, so I created this set. Okay, so the cardinality of that set is, oh, I didn't run it. Okay, so let's see the length. Okay, and it's going to over here. So use the length function. So this is our set. So I'm expecting 1, 2, 3, 4, 5 as the answer. Okay, not the whole thing. Okay, because it's eliminate the duplicates, right? So check on these. Okay, so currently it is 5. Check the membership. So gonna first unblock this. Okay, so all right, so we are going to check is so py is in this set. Okay, so okay, all right, so let me just, so should be right here. All right, and then again the non-membership. Okay, all right, so non-membership. Okay, so check this out. So I'm expecting um, false here. Okay, and this one would be true. Okay, all right, so I got true for non-membership. Okay, membership false. So py is not in here, right? But not py. So basically non-membership is true. Okay, py is not in there. All right. Okay, so the next one is disjoint. Okay, so I'm going to create another test. Okay, all right, and then basically I'm going to check for the two whether they are disjoint or not. Okay, so right here, yeah. Okay, so let's check on that. So I created another set and I'm going to pass it to uh, is disjoint method of a set. Okay, right? So my expectation is, so I have my set over here, so this will be true. Okay, all right. So I got true. Okay, because none of these elements not in here. Okay, so that's why. All right, let's go back. All right, so now I'm going to create another set, different set. Okay, so I think this should be two. Okay, so I'm going to change this to two. All right, so I'm going to unblock. Okay, so basically, I'm going to create. Uh, um, I create another set, and there are two methods of checking disjoint. So one is using is disjoint, the other one is using is subset. Okay, so the set with common elements. In this case, we have three common in both sets. So I create this new, and I'm going to use disjoint uh, over here, and I'm going to block these two lines for now, and then just run this. Okay, and return false, right? So because we have three in common, so it's not a disjoint. So those two sets are not disjoint. Okay, all right. So let's check now the subset. Okay, so we have a set and this one, and I'm going to check this set whether it's a subset of this or not, and then apparently it is, and then I'm expecting true here. Okay, so set 2 now is this. Okay, so it's actually is a set is a subset of this. Okay, so let's check for that. Okay, so I got true. Okay, basically this guy is inside this guy. Okay, subset. All right, let's continue on. Okay, now there are another way to test disjoint, um, and then for subset, um, another way to test for disjoint. Okay, so let's see. So we're going to use this operator. Okay, okay. So here, okay, and this should be subset. Should be subset. All right. So, and then here also, I'm gonna unblock this. So that's the other way. Okay. Let's see. So arrow here. Okay. Okay. So first one is this. So we have it over here, and the other one is, so basically we are using this uh, less than or equal operator to check whether it's a subset or not. Okay. So something over here in this line. I think this should be, yeah, it shouldn't be there. Okay. There you go. All right. So let's run it. Okay. So the first one return false. It's not a subset. Sorry, subset. Yeah. So 4, 5 is not a subset of this. But if we take this one and this, okay, it returns true because this is a subset. This one, this set is a subset of this. Okay, and here this is not a subset of this. Okay. All right. So let's go to our next slide. Excuse me. Okay. So we are continuing on set operations. Okay. The union. So we already learn it in middle school, right? The union of two sets. Okay. Basically, um, right? So new set with element from both, right? So that's the union. Okay. And we can use the operator version of it as well. Okay. And the star here means you can pass any amount of other sets as you want to get the union. Okay, so this star means the parameter can be any number of sets. Okay, and here you can use the operator version, that is basically this uh, this sign, the vertical sign. I forgot which the name of it. Um, yeah, I forgot the name. Anyway, so this sign, and again you can use it with as many you want by separating it with this sign. Okay. All right. So that's the union, and the other command is set operation intersection. Okay, and again you can check as many sets you have. Okay. So and then operator version is you can use the AND operator. Okay. Again, there can be many AND operators along with other as many sets you have. Okay. So it creates a new set with elements common to the set that we are working and the others. Okay. Difference basically it create a set out of removing the common elements. Okay, so again you can have as many number of other sets to check, and you can also use the operator version, and it's basically a sort of subtraction difference, right? So remove the common elements. Okay, so a set minus other minus the other likewise. Okay, and it returns a new set with element in a set that are not in others. Okay, so basically it's it's the sort of opposite of the intersection. So you remove the intersection from the union, right? Okay, all right. So let's check on those. Okay, all right. So this one, side number 7. Okay, so I'm gonna get the okay, all right. So these are the two sets. Okay, um, okay, and then I'm gonna get the union. Okay, all right. So union. So we're gonna get the union of this set first. So basically, I'm not gonna pass anything. So union onto itself. Okay, so you can check that as well. So notice I'm not passing any object here. Okay, and I'm going to check the union with other. Okay, and also I'm going to check this as well. And see that I'm passing more than one now, other two, and this guy. It's also a set. Okay, so right here. Okay, so let's check this out. Okay, I have. Okay, so union onto itself, you get the same set. Okay, see that it's the same set. Okay, and union with other. So other is this, and this is my current set. So it's the both. Okay, so that's the union. And if I pass more than one or a set, like right here, the two and this one, I get that union as well. Okay, all right. So let's go back to our. All right. So this let us check now the union method too. Okay. So okay. So I'm going to unblock this. So in this case, I'm going to use the operator version. Okay. See that this is the operator version. So I'm going to copy paste in there. All right. So now I have this set, and I'm going to get the union between this and this and this, all three. Okay. So we'll get the same result. Okay. All right. So I got the same result. Okay. All right. So let's learn about intersection. Okay. So there are two methods for intersection as well. Okay. So we're going to use intersection method, and then intersection onto itself we can also take. Okay. So that's when we don't pass anything to intersection method. Okay. All right. And the other one is we pass the set. Okay. And then here I'm going to test with two sets. Okay. I said you can have any number of, you can pass any number of sets. So let's try two. Okay. Run it. Okay. So I have intersection onto itself gives me the same set. Okay. Makes sense. And then basically taking the intersection between this and this. Okay. So common elements, right? So 1 is common, 2 common, 3 common, and y and p common. So I get all those as the answer. So y is not there because y is not common to both. Okay. And 4 as well. Okay. So I'm doing the same thing and now here using this and then passing 2. Okay. So, well, that's empty, right? Because now I'm checking whether all three has common elements, but no, right? So see, this set only has 0 and 10. None of these two set has those. So the intersection of these three sets is basically um, empty. Okay, so there's no common element sharing all three sets. Okay, all right. So there's another way of checking for intersection, which is we can use the AND operator. So let's check on that as well. Okay. All right. So this is the oh, I didn't pass it. So let me just pass it. All right. So I didn't run it. Sorry. All right. And here also the two sets I'm checking against. Okay. So run it again. Oh, there's a mistake over here. Shouldn't be this one. Okay. There you go. All right. Okay. So intersection between this and this set is this set. Okay. And like we saw here, that intersection is empty set. Okay. Because none of these the three set has common elements. Okay. All right. So let's go back our slides. All right. This is the one that we're gonna. Okay. So continuing on set operations. Okay. So symmetric difference. Okay. Basically, okay. So it returns a new set with items in either but not in both. Okay. So it's symmetric difference. Okay. So um, okay. So new set with basically it returns a new set with items in either set but not both. Okay. So this operation is we basically only do it with between two, just two sets. Okay, and there's the operator version as well. Okay, all right. So copy, you can use the copy function to create a shallow copy of the set. Okay, and these operations, union, intersection, difference, symmetric difference, is subset and is superset. Okay, and we didn't check that it's superset. You can do it by yourself. Okay, also oops, sorry, also accept iterables. All right, so this So basically, we can pass an iterable. Well, it has to be hashable, right? But if hashable iterable, you can pass it over here and check these operations too. Okay, but operator version need actual sets. Okay, so for example, if I pass, okay, so this is py set, so this will give the same result like this. I am passing now the string, so its string is an iterable. Okay, so these two sets are actually equals. But if I try to do this like the way we saw earlier, okay, to get the union between this set and this string, this is a type error because with this operator, Python needs another set. Okay, so let's check this out. Slide 8. Okay, so let's go down to slide 8. I think we missed checking on the difference. Let me check also that's in the previous slide. Okay, so difference basically, right? So different onto itself. You can check that as well. Okay, okay, and then unblock this too. Okay. All right, and then this guy, difference between another set. Okay, and then the method 2 of difference, basically you use the subtraction operator. Okay, let's check on that first. All right, so difference onto itself. Oh, same set gonna return. Okay, and if you take the difference between this and this, okay, all right, only non-existing, okay, element is basically in this guy. Okay, so right, remember this is our set, this is what we are testing against. Okay, so I am applying the difference operation on this. Okay, and then I'm passing this guy. Okay, so this guy is not in here. Okay, so it returns this. Okay, the difference um, operation. So there's another way to do that, a set minus other two. So that gives me the same result as well. Okay, so let's check the slide 8. Okay, all right, I'm going to unblock this. Okay, all right, so basically in here, okay, I'm going to create set first. Okay, all right, so and then another set. Okay, and I'm going to print that, and then so let's print this. Okay, so method 1 basically symmetric difference. Okay, so we are checking on symmetric difference. Okay, and then here I'm going to pass an iterable and check the symmetric difference. Okay, so this should go back to the top. All right, so okay, all right, oops, should be a set. Okay, all right. Excuse me. So let's run this. Okay, so we have the symmetric difference between this guy and this guy. Okay, so it's actually TYP. So now not only from this guy, both in either of the sets, right? So T is not in here. So we have that. Y is not in here. So we have that, and so is P. So TYP is the symmetric difference. Okay, and for the same, um, using now I'm going to pass an iterable, in this case a list of integers. Okay, so we can do that as well. Okay, so um, right, so this in this case I have 1 2 and the rest is not in the other, so y3p return. Right, all right, so let's check on now the operator version. Okay, okay, so okay, and put it over here. Okay, let's run it. Okay, same result. Okay, so this is the operator version. It's symmetric difference. Okay, all right. So now let's check. So we said earlier some of these uh, set operations can work with we can pass an iterable too, right? But if you use the operator version, you're gonna get an error. So let's check on that. Okay, so this, okay, so let me run it. So I get a type error, unsupported operands. Okay, and it's right here. Okay, so it's gonna log that. Let's go back to our slides. Okay, all right. So these set of operations only sets allow. Okay, and you can see that these are basically modifiers. Okay, so we're gonna modify the set, so then we cannot apply it to a immutable object. Okay, so that means basically these operators only sets facilitate. Okay, all right, update. Okay, and again we can have any number of other sets in there. Okay, and basically now instead of the operator, that we have equal sign as well. So that means basically we are changing the, the original set we are working upon. Earlier we return a new set. Okay, so basically we add element in others into this set. So and then we update. Okay, intersection update. Okay, so basically the operator is and equals. Again, we can have any number of other um, other sets, and we're gonna get basically we're gonna get the same set now gonna get update with only common elements in others. Okay, okay. And difference update, basically again we have any number of other sets, and it's negative equals now, and we are going to update the set, the original set, with the result. So let's check on that. Slide number 9. Okay, so slide number 9, unblock over here. Okay, look up to this. All right, so over here, so I have the other set. Okay, so I'm gonna set before the other set. I'm gonna put that. I think it's a set. Okay, so this is the set before the update. Okay, then I'm gonna update using this command. Okay, all right. So what we're gonna do is basically we'll see a different set. Okay, so let's print like this. So I am printing. I'm executing the update operator. I'm going to print. Okay, all right. So set before update is this. Okay, after updating this set with this, I have this set. Okay. So the set now, it was previously this, now it is this. So we updated the original. Okay. All right. So we're going to continue on to um, intersection update, I believe. Let's see. Um, well, the operator version. Okay. So the operator version. So I'm going to do this. And this is the update operator version. Okay. So that's what I'm doing over here. So let's check on that. Okay. So operator version also. Okay. So before that, I'm actually reassigning, right? See that I'm reassigning the values. Okay. So I have the same set original, and then I'm updating with this, and I have this set now this. Okay. So that's the operator version. Okay. So let's check on intersection update. So we are following the same pattern. Okay. Oops. Okay. So I reassign the set to this, and then printing it, and then doing the intersection update. Okay. So check on that. So original is this. Okay. And I'm checking the intersection with this. Okay. So the common element 1, 2, 3, and that's it. So I now the set is now this. Okay. Okay. So let's check the operator version of it. Okay. Okay. So that is and equals operator. So expecting the same result. Okay. Right. So that's that. Okay. All right. So now check the all right. So there's one more set on intersection update operator version. Okay. So there are two now. Okay. So let's check on that too. So there are three now. Sorry, two sets. One is set, the other, and three. Okay. So the answer is three. Okay. All right. So different update. Okay. So the method one. Okay. All right. So this is the method different update. Okay. And I reset to set this one, and then I'm checking it against the other. Okay. So I'm passing the other one. Okay. All right. So check on that. All right. Difference update. Okay. So it's a different update. So it's a different, we get the difference and then update it with, rewrite it to the original. So these are the two. Okay. So Y not in here and Y and P not in here. Okay. So they said now Y and P. Okay. It's a different update, difference update. Okay. All right. So the operator version of it. Okay. Run it. Same. I got YP. Okay. All right. So the other one is right here. We have one more example. So let's run it as well. Okay. So I have now basically so it should be minus equal. Oh, that's fine. Yeah. So this is the operator version. So I have two sets. Okay. So let's see. Okay. So we got YP as well. Okay. All right. So let's go to slide 10. All right, symmetric difference update. Okay. So basically I have two sets and take basically we update the original by keeping only the items in either one but not both. Okay, so there's only one set that we can pass over here. Okay, all right. So that's symmetric different update, and we can add elements. Okay, so it's one really uh, commonly used method inside adding elements. Simply adds that element silently. Okay, there's nothing returned, it silently adds. Okay, and remove an element from a set, and if we don't have the element that we are trying to remove, you're gonna we're gonna get a key error. Okay, and we can discard an element, so it removes an element silently. Okay, so it doesn't return any error if the element is not in there already. Okay, so it's a silent removal. So it's sometimes it helps to avoid the program crashing, right? Okay, so check on that. Slide 10. Okay, so symmetric different test on that. Okay, so I reassigned my set, and the other is the original one. Okay, so okay, run it. So this is my set, a set, and other. Okay, so basically a set now with the symmetric difference. See that the element that are not present in either is there. So y is in here but not in here, p is in here but not in here, and t in here but not in here. So they're here. Okay, all right. So next one is so the operator version. Okay, so caret and equals. Okay, so we cannot have more than one, right? So this is just one right, like here one, just only one. Okay, all right. So we get the same result. Okay, so let's check add. Okay, unblock this. Okay, so I reset my set to this, and now adding the element 5. Okay, then I'm going to add element 3. Okay, so let's check on that. Okay, so after adding, scroll down. So after adding 5, it's this. So we have the added element. Okay, and after adding 3, okay, we have this. See that it didn't return an error. Okay, so basically we already have this element 3. Well, it's silently rejected 3 because we already have 3. Okay, all right. So this is really useful when you want to avoid duplicates. That's the one of the core application of sets. Okay, all right. So let's check the next one. Next set of operations. Remove. So I'm going to remove 5 from the previous created set. Okay, and then print the set. Then I'm going to try to remove something that is not existing. Okay, so before that, let me try to run this one. So remove 6, and this is gonna get a key error, right? Because we don't have 6 in that set. Okay, so anyway, run. Okay, so we got the set removed 5, so we have it, right? So we have it originally we have 5, and now it's removed, but we got this error right over here. Okay, so Okay, it's saying a key error. Okay, so because we are trying to remove a key that is not existing, basically an element that is not existing. Okay, so let me block this. Now the solution to that is sometimes you want to remove blindly, right? So then basically we can use discard. Okay, all right. So um, in here, so let me just block and run. Okay, and in here basically, well, no error returned. It's the same set. Okay, right. Okay, so let's go back to our next slide, slide 11. All right, so we are not yet done with set operations. Okay, all right. A set pop, so we can pop arbitrary, remove an element arbitrarily. So we don't know what element gonna get removed. Okay, it's pop method. Clear removes all the element in the set. We can basically empty it out. Okay, and these basically so update, intersection update, difference update, and symmetry different update. They also accept iterable, but no operator version. Okay, not in operator version. Okay, all right. So the element argument to remove and discard could be a frozen set as well. Okay, so the element that we are going to remove could be a frozen set as well. Okay, let's check on that. Slide number 11. Okay, the first one, we just, all right. So we have the other set and we have a set, and I'm going to pop out an element and I'm going to print it. Okay. So we don't know what element gonna get removed. Okay. And you can print out this as well. Whether it returns that or not. Okay. So, okay. All right. So, so we, yeah, so it popped the one. So element one. Okay. So we have now the set without that element. Okay. All right. So the other one, other set, the clear. Okay. Okay. So clear is going to basically empty out the set. So now it's empty. Okay. All right. So in this one, I'm going to test it with the frozen set. Okay. So I'm first going to create a set with two frozen set. Right. Frozen sets are immutable objects. So these are immutable. So this is totally legal to create a set out of two frozen sets. Okay. And then basically I'm going to remove one of the frozen set. Okay. So let's try that out. Okay. So this is my set. Okay. Then I removed this frozen set. This set basically it's a set, but it happened to be the a frozen set inside. Okay. So now my new set is without this set. Okay. All right. So let's go to slide number 12. So we said that sets are containers. They are unordered, but they are containers. So they are iterable objects. Okay. So basically we can access element through element by element iteration. Okay. So uh, we know that format, right? We have for loop and for all for elements in the set, and we can do something. Okay. So, however, do not expect an order of the way you see your set, because we said they are unordered containers. So it's really unpredictable the order of the element that you're gonna get out. Okay. But we can iterate elements in a set. Okay. element by element, not index by index, because again, because of sets are unordered, we cannot assign an index. Okay, so index by index iteration is prohibited. Okay, so like I said, index by index iteration is not possible, and index are indexing slicing also as a result of indexing. So slicing a set is also prohibited. Okay, all right. So let's check on that. Number 12. I think we had, okay, number 12. Yeah. Okay. So, all right. So basically, what I'm going to do is I have this set. I'm going to basically iterate. And you can see that the things going to get printed may or may not be in this order. Okay. So that's why I said, okay, don't expect the same order. Okay. So let's check this one out. Okay. All right. So yeah, we can see that, right? So we have one, two, three, and then not py, it's yp. So that's why I said it's unpredictable. Okay, you cannot expect the same order that you have written. Okay, and over here, so let's uncomment this, and now I'm trying to basically um, access the first element via an index, and this is not possible with the set. Okay, so this will return type error. Okay, and that is this. Okay, well, sets are not subscriptable. Okay, all right. So let's go back to slide 13. Sorry. All right, set comprehension, and this is again, like I said, with the list comprehension, really valuable and really a hot topic in interview questions as well. Okay. Well, all right. So set comparison. Okay. So you can we know that we can compare two strings, two numbers, two list, right? Same way we can also compare two sets as well. Okay. So both sets and pros and set support comparison. Okay. So equality. Okay. So set two sets, set one and set two true if and only if every element in each other set. Okay. Um, So basically, each is a subset of the other. Okay. So set one is a subset of set two. Set two also is a subset of set one. Okay. So they are completely equal. Okay. So if that is the case, we return true. Otherwise, no. Okay. So less than. Okay. So set one is less than set two, and it returns true if set one is a subset of set two. Okay. So if set 1 is a subset of set 2 but not equal, then basically this returns true. And we say basically set 1 is a proper subset of set 2. Okay, that's what we say. Okay, greater than, and it returns true if set 1 is a superset of set 2 but not equal. Okay, so we say set 1 is a proper superset of set 2. Okay, so let's check on this. Slide number 13. All right. So, okay. So set comparison. Okay, this is the set two, and I have the set earlier set one. Okay, oh, this is my set one. Yeah, so that's that, and then basically I'm checking the equality. Okay, all right. So check that first. They're equal. Okay, so my set one also this, so they're equal. Okay, and it's true. Okay, and uncomment this one. Now I'm reassigning set 2 to this, okay, and I'm checking which one is great or which one is larger, okay. All right, so this set is less than this and false, right? Because it's the other way around basically. This guy is actually less than this, okay. So this is false, okay, and in the second run, this is greater than this, and yes, it's true, okay. All right, so let's go to our presentation. All right, so list comprehension, okay. So this is again a really valuable operation and like unique to Python. Similarly to set a list, we have set comprehension, and again a really hot interview topic, uh, like list comprehension. This one too, okay. So same syntax, similar in syntax. Instead of two square bracket, we have two curly brackets. That's all. And we are creating a new set, okay, according to this expression. So every element of this new set going to get created by running this expression. And the rest is basically uh, in comprehension, we use a sequence, any sequence, and then iterate the sequence based on the condition, which is optional, and then extract each item in that sequence and then apply it to our expression. Okay. So if clause is optional, okay, expression describe how each element form. For clause basically iterate through each item in the sequence. Okay. All right. If clause filters element according to a condition, and that's optional. Okay. So basically it's sort of a filter. All right. So let's check on this. Okay. So I have a small example over here, simple example over here. Okay. All right. So I have a list. Okay. And basically create it asks, I'm asking to create a set of distinct powers of two of a list. Okay. So I have notice I have repeated twos over here. So I'm expecting only one power of two. Okay. So so that's my set comprehensions. Let me write it over there. Okay. All right. Just all right. So for elements in that list, right? Get the power of it and create a set. Okay. All right. So we are printing that whole thing. So let's print that. Okay. So I got the set of powers. All right. I have 5 to the power 2, 25, 1 to the power 2, 1, 2 to the power 2, 4, 3 to the power 2, 9, but not repeated 4s. Okay. All right. So our last slide is the practice. Okay. So let's go to that. Okay. So it's a little bit complicated problem. Okay. So let's read it again. Given a paragraph of text, write a Python function to find the distinct words that are not present in another given sequence of words. So, all right. So, given a paragraph of text, write a Python function to find the distinct words that are not present in another given sequence of words. Do the following. Solve using list. That's the hard way. Okay. First, we have to solve using list, then solve using sets. And then we're going to apply our the function we wrote to this example. Okay. All right, let's go over here. So I'm going to do an understand umpire process. I'm going to first copy paste this. Okay. So right, umpire. All right. First understand. Okay. So input. Oh, let me just problem. All right. Excuse me. All right. So we don't need this line. All right. So input. All right. We are given a paragraph of text. Okay. All right. So what do we expect? Output. And basically, um, oh, there are one more input. Basically, the other list. All right. Another given sequence of word. Right. Another given sequence of words. It's a sequence. It can be a list, can be a string, can be a tuple. Okay. So output. Basically, we need to find the distinct word that are not present. Okay. So basically, distinct word that are not present in that list. Okay. All right. So let's get an simple example. So let's try to get an example. I think we are given an example in there. So let me just go grab it. Okay. All right. So this highlighted set text should be here. Okay. So yeah, there you go. This is the one. I'm going to get this. Okay. That's from Python standard library documentation. All right. So so let's take a well, take a simple example. Okay. All right, I'm going to text this. Okay. It's a phrase. So this is my paragraph. Okay. Now the other basically the paragraph one, let's say, and the paragraph two. Okay. Let's take like um, let's say like distinct words. Let's say this whole thing, and we can see that. So there's words common to both, right? So basically, I need to return. Okay. So let me make it simpler, more simpler. So I just say, okay, this, okay, and this is the second paragraph. Okay. So words is common to both. So I need to return this set and this. Okay. So basically output. So it's actually a list of. I think it's asking to return a list. Let me see. Given paragraph text right of find the words that are not present. Okay, so basically we can return a list. Okay, so it's a list of these words. Okay, so I need to basically have this whole thing, right? But not words plus distinct. And basically I can return a list of this. Okay, right? So a list of okay, these words in this basically paragraph. Okay, so that's the output. All right. So how do we do this? So it's basically we need to first one thing we need to split this each of these paragraphs, right? So basically right? So basically we need to split this and get each word. Okay, so we need to split, okay, to access each word. Okay, right, need to split. Okay, all right, so let me assume this sequence is actually given as a list of words. So for example, right here, I'm going to take this as a list of words. Okay, like this. Okay, that's my sequence. Okay, all right. So it'll make our life easy down the road. Okay, so need to split paragraph one. So now we have access to all the words. Okay, if you use the default delimiter, and we need to basically iterate and check. Okay, all right, and basically we have to basically do the distinct, right? So distinct words. Okay, not in. So that means if we have like repeated words in here, we only need to have just distinct ones. Okay. So basically, and catch distinct. PNCT. Right. All right. So how do we do this? Okay. So let's write our plan. So match is basically list iteration, um, list creation, even comprehension. Okay. Let's write our plan. Okay. So we need to basically split. So input first, input. Okay. So say paragraph one, paragraph one, two. Okay. We need to input, well, write it over here. List of like words list. Okay. Now we need to initialize the list that we are going to create. Like remember, we're going to solve using list the hard way, right? So init um, distinct words. Okay. And then, okay, so we need to split. Okay. So um, paragraph one words. Okay. So basically split paragraph, paragraph one. Okay. So we have a list, right? So that's actually paragraph words. Okay. All right. And then basically we need to iterate this list. Okay. So the easiest thing we can do is basically um, it works either way. Okay. So we can iterate this list and check against distinct words, or we can iterate distinct word and check against the words in this one. Okay, but we need to check against the this one as well. Sorry, we need to iterate word list and check against paragraph of words, or we can iterate paragraph of words and check against word list. But every time we add a one to this, we need to check whether it's there or not as well, right? Because remember the distinct, right? We need to catch only distinct. Okay. So for, okay, I'm gonna iterate the smaller one. Let's say this one is smaller. Okay. So for words in this one, okay, and then basically we need to if condition, right? 5. Excuse me. So it's not 5, it's 5, 4.1. Okay. So 4.1. Okay. So I need to check these in here. So if they are not in, oops, if words, okay, not in paragraph words, okay, and I need to check against here as well, and not in, then only I add it to right 4.2.1. So now I'm in if condition, right? Insert, okay, or append words to distinct word. Okay, that's it. Okay, we should be able to run this in a this comprehension as well. So, and then at the end, 5 we return distinct words. Okay, so let's write a list comprehension to this one first. Okay, def get distinct words 1. Okay, so we get paragraph 1 and word list. Oops. All right. All right. So what we're gonna do is we're gonna create initialize our distinct words. Okay. So distinct words. It's an empty list. Okay. And then okay, we're gonna create this one. Okay. So paragraph 1 dot split. Okay. All right. So and then we're gonna iterate. Okay. Okay. So I'm gonna copy paste this and change the wording. Okay. All right. So it's on and right here, this one. All right. So not in paragraph word and not in distinct words. See, and so this should be words also. Okay. That's why. Oh, this should be and should be over here. Oops. And okay, and then basically append words to distinct words. So dot append words. Okay. All right. So words. All right. So let's check this out over here. Okay. So okay. All right. So I'm gonna test it out here. It's comprehension. Oh, not site 15. That's fine. So print distinct word and I'm gonna call my function. So let's get that paragraph. Okay. So All right. Assign this to this. All right. And then word list, and it's given to us, right? So the problems, let me go get from the problem. Okay. So it's a list of words. All right. So hopefully it copies properly. Yeah, it's fine. Okay. So word list. So that's our word list. Okay. All right. It should be come over here. All right. So let's run it. Okay. So yeah, basically, well, there's an error. Let's see what it is. List object has no attribute. Oh, append. Append. I misspelled append. APPEND. Okay. All right. Let's run it again. Okay. So, well, I didn't return. So that's why. I. All right. So, oh, I didn't return. That's why. Okay. So it's run. I didn't return the value, right? So, okay. It's testing word. Run it again. So these are the iterations, right? Okay. So we got all the words that are not um, um, well, that's it's just okay. So we got completely opposite result. Okay, let's see what went wrong. Okay, not in paragraph, words not in paragraphs, and words not in distinct words. Okay, okay. Think see we got the auxiliary word list. Okay, that present in there. So we want the other way around. So there's a mistake here. So let's see. Um, for words, so maybe which one I'm iterating? I'm iterating word list. Yeah, okay, that's why. So I'm iterating the word list. So I have to use the words. Yeah, okay. So let's. I'm iterating the word list. Okay, not in. Okay, so I'm splitting paragraph one and words not in. Okay, so I need to do the other way around. Okay, so this should be, all right, paragraph one words. Okay, so it's a classic example of review. Okay, and this should be the word list. Okay, all right, so this should work fine. Yes, okay. So append words to distinct words. So let's correct our implementation too. So this should be this, and right here it should be um, okay. So right here it should be this one. Okay, all right. So let's check that now. Okay, okay, we got the set of distinct words that are not auxiliary verbs in that paragraph of text. Okay. All right. So try to do this in a comprehension. Somehow I said that, but I forgot to do it in a comprehension. Okay. So you can try that out. So it has been a really long time. So let's do a comprehension as well. So I'm gonna re-implement this function using a comprehension. Okay, so instead of returning a list, I'm going to return a set now. Okay, so okay, so let me do it in a list set comprehension. Okay, all right. So return Okay, a set. So you might need some over here. So we need to basically split, right? So need that. Okay. And we have a list given. So I think we are fine. Okay. So, okay. So we're going to iterate. So like we did over here, we iterated paragraph words. So we're going to iterate this one. Okay. So 4 words in this paragraph. Okay. All right. So now basically we need to check whether um, it's not in the word list, right? So if okay, so if okay, words not in okay words list, okay, then grab that word into my set. Okay, so set, the nature of set gonna take care of eliminating the duplicates. Okay, so that's it. Okay, so this is the second one. So let's okay. All right. See, we had to write this many lines of code in set also. You basically gonna eliminate this check. That's all. Okay. All right, and then let run it. So we're gonna go here. Okay. So second one. So I'm expecting the same list, but this case going to be a set. Okay. All right. So we got that set. Okay. All right. And you can, if you want, you can uh, check the equality of both, right? Print. I'm going to pass, right? So both two lists, basically, I'm going to check this guy, the equality of this. Probably maybe we might be, well, let's check. Might get a false over here because the sets are unordered. I'm going to pass this code to a list. Okay. So I'm trying to pass a set to a list. Okay. And let's check whether if they are equal. It's an interesting check. Oh, it's false. All right. Why? Because its the order is different. Okay. So if I can print it over here, can actually print this as well. List. Right. So the order is sets are unordered. So the order of the list is going to be different. Okay. See that instead of Python, I have program over here. So these are two different lists, but have same content. Okay. All right, guys. So that's our very long set lesson. So in the next lecture, we're going to go over dictionary.